Okay, now we can get back to where we left off. Are you able to see the Windows journal screen? I am starting the fourth lecture of basic electrical circuits, and in the previous lecture we looked at what happens when you connect components in series and parallel. It was rather simple, but we tried to do it rigorously so that we get all the sign conventions correct, and in case anybody had any doubts, we also tried to do it rigorously so that all those doubts are cleared. Okay? In this lecture, what we will do is to discuss what are known as control sources. Now, when I say control sources, what I mean is they are either voltage sources or current sources, but the difference is the voltage sources and current sources that we discussed so far, denoted by these symbols, are known as independent sources. That means that their values are not dependent on anything else in the circuit. Their values will be given and they'll be fixed. I don't mean necessarily that they'll be constant with time. We've been considering sources that are constant with time. Later we'll see independent sources which can change with time. But here what is meant by independent is that it's independent of any other electrical variable in the circuit. So consequently, these control sources, which are also sometimes known as dependent sources, what happens is these things, their values will depend on some other electrical variable in the circuit. Okay. So depending on what they are controlled by, we have four different types of sources. We have two types of sources, that is voltage source and a current source, and each of these can depend on either a voltage or a current. So that gives us four kinds of control sources. Okay. There is a question from Harsha. Please go ahead. Harsha? types of sources. A voltage source and a current source, and they can be controlled by, I'll say, type of control, or say dependent on. They could be dependent on either a voltage or a current. Okay, so these two possibilities give you four types of controlled sources. There are a voltage controlled voltage source, and a voltage controlled current source. Similarly, we can have a current controlled voltage source and a current controlled current source. Okay. Now, what is the meaning of a voltage controlled voltage source? A controlled source is denoted by this symbol. We use a rhombus instead of a circle just to distinguish it from independent sources and make sure you understand right away that they are controlled sources. The value of this would be K times Vx, where Vx is the voltage between some two nodes in the circuit. Okay. Now it is very important to understand that this Vx is not something that I apply from outside, but it is any voltage in the circuit. Okay. I'll call these NA and NB, and these two are any two nodes in the circuit. Okay. Now, what does it mean? Just to give you an example. Let's say I have V0 connected to two resistors R1 and R2. The current flowing here would be V0 divided by R1 plus R2, because the series combination of the current, so series combination of the resistors results in a single resistance, which is the sum of the resistances, and the voltage across this is V0 times R2 divided by R1 plus R2. Now I could have a current source controlled, I could have a controlled voltage source, a voltage controlled voltage source in the circuit, which I will show in red. That is, let's say K times Vx, and Vx could be defined to be this one. Okay, so Vx is something that is given to you in the definition of the circuit. Now in this case, what it means is the voltage across these 2 points would be K times V0 times R2 by R1 plus R2. Okay, so it very much depends on what this Vx is, and Vx is the voltage between these 2 nodes in this particular circuit. So in general, Vx could be defined to be anything, that depends on the circuit, and the voltage of the voltage controlled voltage source will depend on Vx. Okay, so that's what is meant. And also this K is the constant, a property of the voltage controlled voltage source, and it is dimensionless, as you can easily guess. It's a dimensionless constant. Okay. Now the next type of control source is a voltage controlled current source. Now again, the symbol for it is similar to that of a current source, but with a rhombus instead of a circle. And what it means is the value of this will be some G times Vx. Again, Vx is the voltage between some 2 nodes of the circuit. Okay, so let's say we have Na and Nb. Vx is the voltage between Na and Nb. So what this means is this will maintain a flow of current which is dependent on the voltage between Na and Nb. Okay. So again, taking the same simple example, so if I have V0, I'll have V0 R2 by R1 plus R2 across the resistor R2, and I could have a controlled current source which is G times Vx, where Vx happens to be defined like this in this circuit. Vx is the voltage between these 2 nodes. So what this means is this will the controlled current source will force a current which is equal to G times V0 times R2 by R1 plus R2. Okay. So if you, let's say, you connect a resistance to this R3, clearly we cannot have a current source with nothing connected to it, though sometimes we draw it like that. In a circuit, for KCL to be satisfied, a current source always has to be connected to something where the current can flow. So here, let's say it's connected to a resistance R3. What happens is that the voltage across R3 would be G times R3 times V0 R2 by R1 plus R2. Okay, basically it is equal to G times Vx, the current source value, times R3, and that in turn equals this one. Okay. So this is what a voltage controlled current source does. Okay. it looks at the voltage between some nodes and gives you a current that is related to this Vx, okay, where Vx is the voltage between certain nodes, okay. So again, what is most important to understand is that I have not connected a voltage source Vx to this whole thing. Vx happens to be some voltage in the circuit which is defined appropriately, okay. And next we can consider current controlled sources. Let's say I have a current controlled voltage source. What it means is that it is a voltage source whose value depends on some current in the circuit. And what is this current Ix? There is some wire or some branch in which a certain current Ix is flowing, and the value of this voltage source depends on the current Ix. Okay. So again, I will take the same example. V0, R1, R2. The current flowing here is V0 divided by R1 plus R2. And let's say I have a current controlled voltage source, okay, and the current controlled voltage source is defined to have a value R times Ix, and in this case let's define Ix to be the current flowing in R2, okay. Ix is the current flowing in R2, okay. What it means is then the voltage across this would be R times Ix, which happens to be equal to R times V0 divided by R1 plus R2 in this particular circuit, okay. Now, first of all, one thing I have to point out here, this is a dependent voltage source and the voltage depends on a current and it is directly proportional to a current, okay. And this constant of proportionality, it is multiplying a current and giving you a voltage, okay. The voltage across this is R times Ix, so the constant of proportionality has to have dimensions of resistance. Okay. Similarly, in the previous case, this constant of proportionality multiplies this voltage Vx to give you a current. So this has to have dimensions of conductance. Okay. And finally, we take the last of the dependent sources, which is a current controlled current source. Again, it is a current source, but the value depends on another current. Okay. That is, the current being forced by this current source equals K times Ix, where Ix can be any current in any part of the circuit. Okay. So Ix is flowing through this wire. So in general, you would define the current through some branch to be Ix. I will yet again take my voltage divider example. R1, R2. The current flowing here is V0 divided by R1 plus R2. If this voltage is V0, okay. And let me define a current controlled current source to be some K times Ix, where Ix is the current through R2. This is something that I would define. Okay. Now, what it means is that this current source here will force a current which is K times V0 by R1 plus R2. Okay. Meaning, if I connect a resistance to it, this will force a current K times V0 by R1 plus R2, which means that the voltage across this would be current times the resistance K times V0 by R1 plus R2 times R. Okay. So that is the definition of a current controlled current source. Okay. So that's the definition of all the four control sources. Now this constant of proportionality, it is multiplying a current to give a current, so it is dimensionless in this case. Okay. So just as a quick summary, we have four types of control sources. Voltage controlled voltage source, voltage controlled current source, a current controlled voltage source, and a current controlled current source. This is abbreviated to a VCVS, and this is VCCS, CCVS, and a CCCS. And a voltage controlled voltage source gives a voltage equals K times Vx, where Vx is some voltage in the circuit, and voltage controlled current source forces a current G times Vx, where Vx is some voltage in the circuit. Current controlled voltage source provides a voltage across its terminals, which is some R times Ix, where Ix is some current in the circuit. Similarly, current controlled current source forces a current through it, which is K times Ix. Okay. So those are the basic definitions. Now I went through all the four definitions because they are sort of routine. Now I will take all the questions. Any questions that you have regarding control sources or anything else? Okay. Okay, there are a few questions. One is, can the control source be dependent on some value that is given by an independent source? Okay, that is, let's say I have a VCVS, that is a voltage control voltage source, and this says that this is K times Vx. Now, Vx is defined to be the voltage between these nodes. Yes, this voltage can very much be given by some independent source. This is entirely possible. Okay, it depends on the circuit. Now this V0, I mean basically this voltage control voltage source, which is this part, gives you a voltage which is K times this voltage minus that voltage. Okay. Now that can be any value. It can be given by a voltage source. It can be a result of some other complicated circuit. All you have to do is define these two nodes across which Vx is measured, and that can very well be across an independent voltage source. Okay. So that's possible, and it's also possible that it comes from yet another dependent source. Okay. So let's say this Vx could be the result of a current control voltage source where this Ix is the current flowing somewhere and this voltage source is R times Ix. Okay. All of these are possible. That Vx can be anything. It has to be some voltage defined properly in the same circuit. That's all that's there to it. Okay. Now, whether Vx comes from an independent source or a dependent source, all that doesn't matter. That's only the detail of the circuit. Okay, it can be the voltage across a resistor, or in case of a current controlled case, it could be the current from an independent current source or a dependent current source, whatever it is. Okay. And the other question was, how do I find the value of K and so on? Now these are given to you. Okay, normally, if you have an independent voltage or a current source, all you have to do is to specify the value of the voltage or current. Now, if you have a dependent source, let's say voltage controlled current source, you have to specify Vx, that is the nodes across which Vx is defined, and again Vx, the voltage has a polarity, so you have to say which is the plus and which is minus of Vx, and the value of K. Okay, that's a given. Just like you give the value of a resistor or an independent voltage source, you have to give the value of K. Similarly, if you have a voltage controlled, if it's a voltage controlled voltage source, you give Vx and K. Voltage controlled current source, you have to give Vx and G. All this will be given to you. Current controlled voltage source, you have to say what Ix is, which direction it is, and some R, which is the proportionality constant, and a current controlled current source, Ix and K. Okay. Okay, now it looks like though I finished with all the questions. Now my question for the participants is, are these sources linear? Okay, we discussed 4 types of control sources. Are they linear or not? According to the definitions I have given.